Hey there folks, I got this aquarium here and we're going to use it to model a system. The specific system we are going to model is when a cold front meets a warm front. This often causes extreme weather such as lightning, hail, and it also can cause cumulonimbus clouds, which that's just fun to say. I have an aquarium here. I have a divider in it made out of Legos, and I have a cold side and a warm side, but how are we going to tell? We're going to use blue for cold. Check out the water. There's some cool swirling patterns as it disseminates throughout the container. Now, time to let the red go on in. It should disseminate a little faster because it should be warmer than the cold water. Remember, temperature is just the motion of particles in a system. This right now, I put some ice cubes in here and they melted, and this is about room temperature. But I need this water to have a larger temperature difference. I have a tea kettle of boiling water, and I have a jug of water that's been in the fridge. I'm gonna pour those into here so we can add a lot more warmth and cold into the system. Friendly reminder, cold is simply the absence of heat. So we're gonna add heat and less heat into the red and blue water. And then I'm gonna remove the barrier, and then we are going to watch what happens. You ready? Because I know I am. Good versus evil, hot versus cold, fire versus ice. Except it's just water and food coloring. We are going to use our tactile thermometers to see how warm it is. First off, the cold one. Ooh, pretty icy cold. Let's see this warm one. No, it's just a little warm. Now that I've proven to you through tactile thermal measurement, I want you to make a prediction down in the comments. When I remove this divider, what do you think is gonna happen? Warm front meeting cold front on 3, 2, 1. All right, so you may notice some of it is mixing to create purple, but the red is up top and the blue is on the bottom. I don't know if it's coming across on the camera, but you can see little tiny ripples moving, and you can see there's a convection current that is forming. The reason why the water itself is lighter, warm liquid and warm air has a slightly lower density than cold liquid and cold air. There you have it, folks. We created purple water. But I hope you learned about convection and warm fronts meeting cold fronts along the way. If you found this video useful, don't forget to like, subscribe, hit the bell button, whatever you want to do, and have a good one. Bye-bye. That's good.